So today we are going to focus on auto summarization. You see, EIGRP by default will do auto summarization. What is auto summarization? Let's take this topology, which you already know, familiar with. And let's say you got some networks like 172.16.1/24. This is on loopback 1. Loopback 0 already has got this. On loopback 1, I'm going to give this. And again, another network 172.16.2.0/24 on loopback 2, 172.16.3.0/24. Like this, we have some networks assigned to loopback interfaces. When you run EIGRP on this router, what you will say? You will say network 172.16.0.0. What is the default class? 172 means what? What is the default class? What class it is? Class B. So class B is /16. And this is subnetted, right? This is subnetted. When you say network 172.16.0.0, this 2 octet is matching on all these 3. So EIGRP will be running on all these 3, but while advertising, it will advertise class full. It won't advertise the subnetted mask. Instead, it will advertise 172.16.0.0. You know why? So that on the routing table of these routers, it won't be too big. The routing table won't be too big. Instead of advertising 3 lines, it is advertising a summary of that 3 line. That obviously reduces the size of router B and router C's routing table. That's the advantage. Advantage is to reduce the size on the router that receives the update. What is the other advantage? When the size of the routing table is smaller, the time taken to process will also be less. So your network will be more faster when the routing table is smaller. Summarization is good. Now, if I ask you what is summarization, what should be your answer? Summarization is rounding to a classful network boundaries. Rounding to classful network boundary is auto summarization. What summarization? Auto. See, it is rounded to classful boundaries. 172.16.0.0 is common for all these 3, right? So this means all these 3. This is what by default RIP version 2 as well as EIGRP will do. But if you want a detailed route, then only you need to say no auto summary. This no auto summary command you also used in RIP. We also have in EIGRP, so that the auto summarization is cancelled. When you type no auto summary, what happens? It starts advertising these 3 lines. Not the summary, it is going to advertise detail when you cancel by putting no auto summary. I'm going to show this in action, then you will understand better. As we already planned, we'll go to this router, add some more loopbacks. This I'm going to configure and then I will advertise. First, let me configure under loopback interface. Interface loopback 1 IP. See, after I configure, you're going to do it. I'll wait for you to do it. And sometimes, surprisingly, I'll ask you to show by sharing your screen. So be ready. 172.16.1.1. But do not do when I'm doing. See, I have given 24 masks. The default is 16, but I have subnetted. Next. Sorry, loopback 2. Okay. Show IP interface brief. You can see 3 loopbacks. You can see 3 loopbacks. Now, show IP EIGRP, the show IP protocol. You can see those loopbacks are not advertised. You have loopback 0 and you have G00 and G001 involved in EIGRP. Other than loopback 0, you don't have any other network, any other interface. We are going to now advertise by saying router EIGRP10 network. We say if 172.16 matches, and all those interfaces you run EIGRP. So now I should see 3 more interface. Yeah. So loopback also now, loopback 1 to 3 is also now involved. And 172.16 is matching on this 3 interface. Now, when I go to router B and check the routing table, show IP route, I can see only one line, a summarized one. Did you understand now what is that summarized update, summarized route, auto summarization? Did you understand? What about Priya? Did you understand? So, summarization is good. It keeps the routing table simplified. As a result, the time taken, CPU utilized, all are going to be less. And the end result will be our network will be more efficient. But if you have a genuine reason to learn detailed route instead of the summary route, you need to go to router A where the summarization is done and cancel that summarization. By default, summarization is on, but I'm going to cancel and show you now. I will say router A, router EIGRP20, no auto summary. We are doing what? No. We are doing what? Canceling that default auto summarization. I hit enter and you will find, sorry, I made a mistake. It is not 20. We don't have 20. What is that we have? 10. No, not like that. I have to go back to EIGRP 10 where I would like to cancel the summarization. If I cancel under EIGRP 20, I don't have any interfaces in EIGRP 20. So no way it is going to impact. I have to say router EIGRP 10. You can use 11, 12, 13, 14, 20, 200, 2000. You can use up to 65535. Any number, your wish. But if you are going to do some alteration, you need to go back to that same number which you used earlier. That is why I'm going under 10 and say no auto summary. As soon as I say it is doing resynchronization, now you go back to router B and check the routing table, show IP route. You see now the detailed route. It's not a summarized one. Do you understand now summarization, auto summarization? What, Mitra? So we got detailed route here on RP. After I cancel the summarization here. Okay, 1 minute. Just look at my screen now. One more thing I want to show you. Because we have put no auto summary, now when I type show IP protocol, I should see not. The next number after the slash is the composite metric. Because the composite metric is same for router D to reach this network, or from router D to reach that network, it is same via router B 102301 is B. And it is also same via C, which is 103401. So from here, you can go this way. You can also go here via the bottom way. All right? Okay. So this is the routing table of router D. Next, what we are going to do is we are going to learn authentication in EIGRP. Authentication in EIGRP is, now let's focus on EIGRP authentication. Why do you need to authenticate? See, if you hear some sound in the door, before you open, you authenticate. You want to know who is knocking at the door. Right in the midnight, if someone is knocking, we don't just open like that, dumb people. We are not that dumb. We want to know who is there on the other side. Once you hear the voice of some known person, only then authentication is done. Only after that you open the door. Same way. This is one router running EIGRP. Let's say autonomous system number 10. And this is another router That is also EIGRP 10. What will happen? They will form neighbor and they will start sharing everything. What if this is a bad network, a rogue? What if this one is to destroy your network? See, if this gives some root, because they are both in same autonomous system, these two will form neighbor, and this started giving roots which are not truly valid. How can we avoid our router forming neighbor with a rogue router? How do we avoid forming neighbor with a rogue router? By authenticating. When this guy send hello, you want to authenticate. Is he a right person sending me the hello? Or should I avoid receiving the hello? Based on authentication, you can take a decision. You can check whether R2 is giving the correct password. When you put the right password for your laptop allows you inside. Likewise, if router 2 comes with the correct password which router 1 knows, then only router 2 will accept the hello sent by router 2. Even though this is the topology. Even though they both have got same routing protocol, even though they both have got same autonomous system number, it won't form neighbor unless they both have the same password. Yeah. So authentication is very important to decide whether to accept someone's hello. If someone's hello is being accepted, after that only the sharing of update all comes. So accepting as a neighbor is very important. Once the neighbor is established, then all the updates will start coming and filling your database. And what if those updates are bad updates? That's why we want to authenticate, and after authentication you want to receive the update. Authentication is good. But but when I send a hello packet with a password, let's say on both the router I set password as Cisco 123, Cisco 123. What if someone using a Wireshark capture the packet and know the password? Then there is no use of enabling authentication. To avoid that, EIGRP supports only encrypted password sharing. It won't share the password like this openly. Cisco 123, it won't send like this openly. It will hash it and send. And because both the side password is same, when they do the reverse hashing, they will get the password, and password matches, they accept. Hashing is encrypting and sending the packet. So when it is decrypted, the real password will be revealed. So the rogue devices, without authentication, they cannot form neighbor. Even if they belong to same autonomous system, they cannot form neighbor. And if they try to sniff a EIGRP packet to know the password, they can't know it. The reason is it is encrypted, it is hashed. What is the algorithm used in hashing? MD5. MD5 is the algorithm. Did you understand why authentication and how EIGRP does encryption or hashing? Now we are moving on to the configuration side. For that, what you do is you don't need to build a new topology. Just click this one and wait. Click this one and disconnect this wire and this wire. We will test authentication between router A and B. We will test authentication between the router A and B. So I'm going to router A. Please focus on the screen only. Don't do it. Right now, if you go to A and check the neighbor show IP EIGRP neighbor, you have router B as a neighbor. Router B is the only neighbor now. Let's enable authentication. How do we enable authentication for EIGRP? First of all, you need to create a key chain. What chain? Key chain. Key chain. Give any name. I'm going to say ABC. ABC is the name of the keychain. Key ID 1 means first key. You can have many keys. Let's have only one key today for today. Key 1. What is the key string? Means what is the password? Done. Keychain is ready. What is the name of the keychain? ABC. Now what I need to do is I need to go under the interface and put this keychain, lock it. Where? I have to lock the door. Where is the door for the router? This port is the door for the router, right? So I go to the port, interface G000. Yeah, I go to this port and say IP authentication for IP authentication keychain keychain for what? For EIGRP 10 is ABC. As soon as I put this keychain, there is something going on, something happens. Go to router B and check now. Show IP EIGRP neighbor. You see the timer here, 11, 13, 12, 11, 10, 15. Okay, what about here? Show IP EIGRP neighbor. 10, 13. It's coming normal. The reason is we did not actually enable the authentication. That is why it is still having the neighbor. See, we added only the keychain. But where is the lock? Let us put the lock. Now you see, we go under the interface G000 and say IP authentication mode for EIGRP 10 MD5. This is what the lock. Now, as soon as I hit enter, the neighbor went down. It won't come back. Until you configure the other side with the same password, it won't come up. You try typing now, show IP EIGRP neighbor. You see the neighbor gone down, disappeared, gone down, finish, no more. The neighbor is gone. What about on router B? On router B also it is very clearly said authentication failed, so neighbor went down. Neighbor went down. So let us now check the routing table. Show IP route EIGRP. I don't learn any route from. This is coming from where? 10.0.0.2. 10.12.0.2. Who is 10.0? 10.12.0.2 is this one. It's still holding it. It will be removed soon. They're still holding it. There is no neighbor now to give. Show IP EIGRP topology. Yeah, this is old entries. It is still holding it. So let us refresh to get the latest. Clear IP route start. This will show you the latest one. Still there. Clear IP EIGRP. Clear EIGRP. Clear IP EIGRP. This is a simulator, so you don't have this commands to refresh EIGRP. But what I can do is show IP EIGRP. EIGRP neighbor. This very clearly says that there is no neighbor to give any routes. But I in the routing table, I still have this because it is still holding the route in the topology table, which is not normal. In the real device, this never happens. When the neighbor is down, and then this is the neighbor address. When the neighbor is down, automatically these things will be removed. That's how the real device works. Now, let us go. Okay, one thing I can do. It is showing the routing table, right? But when I ping this 3.3.3.3, the ping is not going to. What? Where is this ping? Okay, it is having the route, no? The old route, that is why. It's pushing the packet via that direction. In the real device, this is not possible. This will be removed instantly because the neighbor has gone down. And the proof to say neighbor has gone down is we don't have the neighbor in the neighbor table. Now, let us now go to router B to bring the neighbor back. Oh, I made a mistake. How to avoid this? I should have typed no IP domain lookup. Now, let us go and configure keychain. Name can be anything. There I gave ABCD. Here I can say LKJ. Key ID 1. Key string. This should be same. Cisco 1, 2. Now let us go under the interface. What is the interface name? G000. Interface G000. IP authentication mode EIGRP 10 MD5. This puts the log. IP authentication type authentication key chain for EIGRP 10 is LKJ. That's it. See, the neighbor immediately came up. Now go back and check on router A. You should see the neighbor Yes. Neighbor, you have the neighbor now. Show IP route. Okay, fine. So we have seen how to enable authentication, EIGRP authentication, and we also learned that it uses MD5, so that password will be sent encrypted. Now your turn.